In your lesson notes for lesson 11, you'll find a review in preparation for the first exam or comprehension assessment test. And so in that very first problem, note that all that's being asked is for you to draw an appropriate and complete free body diagram of specifically bar AB. It's important when you draw these to get them relatively at the same kinds of angles and everything. It makes your life in terms of accuracy much easier. So I've got that bar spread out there. Notice that the bar is at an angle of theta equals 20 relative to an inclined slope of 15. So with respect to the horizontal, that is actually of course a 35-degree angle. You know that we're given a mass m. In upcoming blocks you'll figure out exactly where that center of mass is, but it's sufficient here, for instance, to show the weight as just a vector moving downwards. And that's what's sort of driving this whole sort of problem. You've got the cable force that is 30 degrees with respect to the vertical. And so if we're going all the way and cutting the free body of B, we've got to cut the cable down here. And so that cable, single cable, wraps over the pulley, no friction, so therefore it's the same value T that we have there. We have two rollers at A and B, so that means we have a single unknown that happens to be then perpendicular to the plane in which they're acting. So there's your force B, only one unknown. You've got angles here then that are 30 degrees with the horizontal for B, 60 degrees from the horizontal for the cable force. And then down here at A, there's when you're tempted to draw perpendicular to AB, but it's not. The plane is at 15 degrees to the horizontal, so you have to get that in there properly also. And so then that turns out to be 15 degrees with respect to the vertical finally for that force A. And that's the answer that's complete and appropriate for problem number 1.